In this particular presentation, we're talking about proper wire connections, kind of the most underrated player on the team when it comes to an irrigation and lighting system. Some people overlook these things. We want to give you the top points about how to make a good connection and how to spot a bad connection. So we're going to get into that a little bit more in detail. But before we do, let's get into the panelists right now. I mentioned myself. I'm Greg Rosink, upper left corner. Ryan Williams is the Director of Marketing for Lighting here at Hunter Industries and FX Luminaire. He's been with the company for a long time. Ryan was with FX Luminaire before it was acquired by Hunter Industries. Was that 11 years ago now? And Ryan has really upped the game in the lighting world, and he has a lot of knowledge on this subject today about wire splicing for, or wire connectors for lighting. With that, I'm going to leave it there. And George Cole, field service manager, is been with Hunter for probably as long as I've been alive. And he's out in the field every single day solving these problems, and he sees these connection issues all the time. And one of the guys that has harped on me for so long about the importance of a good connection. So he's going to be a really good topic of conversation today when he gets into the irrigation side of it. Now, if you don't know who your field service manager is today, please reach out to your sales manager and find out who they are, because they can help you with so much. Now, if you don't know who your sales manager is, you can reach out to me and I'll get you in touch with your sales manager. But that takes me over to our sales manager on the call for today, Patrick Freeman, who's over in the east part of the country. And Patrick actually was just out on a call this morning, he mentioned, and deals with these types of wire connection issues all the time. Calls from customers saying, hey, it's Friday afternoon, I got to get going, but I can't get the system to start running. So Patrick's really going to kind of key us up for what we're going to talk about in this conversation today. And he's going to have some insights throughout the presentation that'll really resonate with a lot of you guys that are out in the field doing this day by day. So Patrick, why don't you tell us what we're going to learn about today?
Good afternoon, everyone. Patrick Freeman here, coming to you from North Carolina, so I can say good afternoon. We just turned over to noon here, lunchtime. And today's topics are going to be a discussion about some common issues that me as a field service manager, I get a lot of phone calls about electrical problems. Folks out in the field are pretty good at identifying water leaks and things like that. They're pretty easy to identify, so I don't get a lot of calls about those. I get calls about electrical issues. And what I'd like to talk about real quick is the field service manager position is relatively unique to Hunter Industries. It's another layer of support that we have that our competition does not typically have. So just another value added support role that we have at Hunter Industries, helping you folks as the contractors and the ones out there in the field with your problems that you may have. But George and I both, we get a lot of phone calls about electrical issues. Electrical issues are going to happen obviously in the wiring system. Well, at Hunter Industries, we deal with both irrigation wiring and we deal with lighting wiring. There's a lot of similarities between those types of electrical systems, but there's a lot of differences as well. So today we're going to discuss similarities and what wire splices have in common amongst irrigation and lighting systems, and we're also going to discuss those differences. But folks, if we think about it, when we have electrical problems, rarely does a wire spontaneously combust. You know, wire just doesn't really go bad. Where we typically have our issues in wiring systems is where we as contractors, or the human error side of things, and that's typically made at the splice. As Greg mentioned this morning, I was on a 2-wire job site in the eastern part of the state, and as we start troubleshooting things, it was very quick and obvious to me that our issues really were back to the original install and not using proper techniques when making those splices. Again, human error came into the fact, and these are things that could have been avoided had we known what we were doing from the get-go. So today's presentation is going to introduce you all to these two types of electrical systems, how to properly splice these electrical systems and these wires together so that we can avoid having these problems down the road and help you identify them once we see them in the field.
All right, thank you, Patrick. This is Ryan Williams here. I'm going to take it over for the next couple slides and the next few minutes here. So the most important rule or rules for any connection fall within 3 different categories. They are, you can see on the screen there, they are strain relief, metal-to-metal contact, and waterproofing. These are the 3 rules or 3 pillars for any connection. And if you ever find that you're falling short on one of these 3, eventually your splice will fail. And whether it's a lighting job or an irrigation job, you're going to end up getting called back to the site. Okay, so let's talk about these three rules or pillars here. The first one is strain relief. Strain relief is the ability to pull apart a splice. If you've ever tried to grab 2 wires and rip them out of the wire nuts just by yanking on them, that means you have very poor strain relief. This is all about trying to make sure that this thing's never going to come apart or get pulled apart, whether it's from a trimming tool in the yard, whether it's from kids running around or anything. You always need to have some type of strain relief. Number 2 is metal-to-metal contact. This is what we commonly know for wire nuts, right? You twist your 2 wires together, then you put a wire nut on and you twist it a little bit more just to kind of get it a better contact. Metal to metal. That is where everybody starts, but not everybody finishes. The third category is waterproofing. I think we're all very much aware of the need for this, but not all of us have gone through the pain just yet to realize how important it is. Waterproofing can be done in a number of different ways, and I think we'll get to talking about that later down the road here. So when we talk about these 3 rules, oftentimes we'll find ourselves doing 1, 2, or hopefully 3 of these at any given splice. So a classic example would be a wire nut, right? A wire nut has decent metal-to-metal contact, but it does not have strain relief because I can rip those wires right out, and it does not have waterproofing. Okay, so we know from that case right there that some work can be done on just a simple wire nut. Let's step it up another level. Okay, the next level for, I know that's common for lighting, is waterproof wire nuts, right? Or gel-filled wire nuts. In that case, what have we done here? We've checked off 2 of the boxes now. I now have metal-to-metal contact, and I have some waterproofing built into those wire nuts. Great. Okay, that's better. We've got 2 out of the 3. But just remember, the metal cap inside of a wire nut does not constitute strain relief for outdoor connections. You have to plan for that 3rd tier. And if you're not planning for that, then eventually things are going to fall apart. Okay. There are various ways to add that 3rd piece for strain relief. In some cases, I know George is going to talk about a few of some of the DBRY splices that are used to add some strain relief. Others will use zip ties as an easy way to do strain relief. Even tying the splice into a knot will give you some additional strain relief. There are some more mechanical ways of doing that, some more popular splices, as well as I would say more of the ultimate options where you have these brass tubes or crimping options for each side of the wire, and then you have a heat shrink tube over it. In all cases, no matter which splice you use, I'm not necessarily preferable to any one here, especially on the lighting side, but my only concern and need is that we're doing all 3, strain relief, metal-to-metal contact, and waterproofing. And if we stick to something that does all 3, then we're going to be in a pretty good place. So one other piece I wanted to add is, again, this is for the lighting piece only, and I think this is really this last slide really that's lighting only. But let's kind of chat about what the compliance needs are when it comes to lighting. So this is the UL 1838 code, and this is the only part I'm going to bore you here, I promise. It says the connectors used to connect a luminaire or output circuit component to the main low voltage cable shall be a copper or copper alloy or the equivalent. And here's the part I want you to understand or pay attention to. When installed, the connection shall guard against inadvertent shortening of the current carrying parts. Wire nuts are not to be used unless provided with corrosion protection and intended for outdoor use. So for all those contractors out there and that are just using wire nuts, technically you're not putting in a UL certified or listed system according to 1838. So you do want to make sure that you are covering your own liabilities by following all of the guidelines in terms of making sure it's a secure system. So it says wire nuts are not to be used unless provided with corrosion protection. So we talked, that's the waterproofing mechanism. And the piece I would add, remember, because it doesn't talk about that strain relief piece. So we just want to add that we're adding strain relief to these systems. Okay, so with that, I'm going to turn it over to George here, and he's going to kind of run into more of the irrigation wire connections, and we'll even get into troubleshooting as well. But remember, if you remember anything from today, strain relief, metal-to-metal contact, and waterproofing. All right, George, take it away, buddy.
So we're going to talk about getting exactly what he was talking about. We have strain relief, which usually means a little bit of extra wire, guys. You can't stretch wire. We're going to talk metal to metal again, and we're going to talk about waterproofing. And we're also going to talk about locations for the splices. They need to be in a valve box. You need to be able to find them because nothing's worse than not knowing there's a connection, down in the ground somewhere and you're having issues. We're going to talk about cutting the wires. When we're cutting the wires and we're starting to strip them, I'm going to show you why you want to make sure that you've picked the appropriate gauge on the tool as you pull the insulation off. And again, slacken the wire, pull it up in the box. On the 2-wire paths on irrigation, we want more than we're going to require in lighting, but you still want to have a little bit of extra because if you have a really good waterproof connection, you're going to have to cut wire and you can't regrow the wire. So we're going to want a little bit extra. So when we cut it and we restrip it, that we have enough wire to remake the connection. So if you take a look here, this is what we're talking about. So on your wire, on your tools that you do to take off the insulation, if you use too small of the orifice, the cutting edge, you're going to nick the wire. You can see the nick here. You can see the other side was done correctly. This nick can break. So when you're making your connections and you're twisting the wires together, this right here could create a fatigue on the wire. And as you're tightening everything down, the wire breaks, and now the connection's not there. You might have metal to metal in the wire nut, but since you actually broke the wire, it's the end of the connection. It doesn't work anywhere past that point. Here's a couple of the 2-wire decoder connections. It's a little bit different. So what you have on lighting, you have about 15 volts on the wire path, and it's only when the system's coming on. With 2-wire, a lot of times you have voltage on the 2-wire path consistently. So you have to make sure that you have a different connector. That connector is required to be able to be like UL approved for 24 volt or 24-hour voltage. A lot of connectors are only good for temporary, which could be 6-12 hours, but not for 24 hours a day. So that's why you usually end up using special connectors for a 2-wire path, decoder path on irrigation, is because you have constant power on there. And these are exactly the same connector. One's just a little larger than the other one for the different wires. This is very important to know, because one of the things I see all the time is I see these connectors improperly installed. So what you want to do is there's 2 different methods you can use. Some guys will just use a wire nut. So you'll put the 3 wires together. Let's say you put the wire nut in there and you use the wire nut to make the connection. That gives you an okay connection, but remember, we're looking at metal to metal. So if you take those 3 wires and you take a pair of pliers and you twist them together really nice and tight, they have a lot better connection on the metal to metal. That also ensures that now you can drop in maybe a decoder wire on top of that, and it makes it easier to remove and replace just the decoder. The wire from the decoder doesn't get intertwined and got caught in your 2-wire path. That also ensures that if you take this connection apart at a decoder, that the 2-wire path can stay intact and you don't have to worry about it breaking free. You push you're going to push the connector into the DBY, and you're going to feel a little bit of click, and then you're going to pick it up and push it in. Pick it up about 3 times, about 1/2 inch, because you're trying to get that grease back over the wires. Because if you just push it in there, you're going to leave a funnel hole. And when you put this into the valve box, if you get water in the valve box for some strange reason, irrigation tends to fill up valve boxes, you'll get water to work its way down into that wire net. And once you get water onto the wire, no matter what it is, lighting, irrigation, once you get water onto that wire, you're not going to get rid of it. It's going to stay there. Once you end up popping it back and forth a few times and you get the grease over it, you can snap the end cap on, and there you go. You'll notice that there's 3 wires. So these particular connectors are designed for like 3 14-gauge wires or 3 12-gauge wires, plus maybe 1 18-gauge decoder wire. Do not cram 8 wires into this connection. It will not work. Here's our strain relief. Our strain relief is 4 to 5 extra feet of wire for each leg. So you'll notice that I have, let's say I have an incoming 2-wire and an outgoing 2-wire. So I'm going to have the incoming side is going to be about 4 to 5 feet. The outgoing is going to be about 4 to 5 feet. And you should be marked the outgoing wire and the ingoing wire back and forth. So when somebody else gets in the box, they know which one's which. Again, like I said before, on this decoder connection, if you're going to add a decoder to this particular location, twist your 2-wire together first, and then just add your decoder wire last. That way, it's easy to remove when and if you need to remove it.
Hey, George, can I add something here too?
Sure.
Yeah, so it is common for contractors, if they're putting in irrigation, they'll use these DVRYs, and oftentimes they'll use these same connectors for the landscape lighting side. I would recommend that 3M actually makes similar ones that are for landscape lighting only. They're a little bit bigger and they're black, so which is nice because they kind of blend in with the ground a little bit better. They're also bigger in diameter because, as you can probably expect, I mean, the decoder wires and small, let's say 18-gauge wires can fit in there pretty well. But when you're trying to put in a bunch of 12 gauges in there, it doesn't work that well, and it's really hard to get all the gel fill to get all the way in there. So I definitely recommend not using these blue ones for lighting. Either if you're gonna use this type of style, which is great because it checks off the three colors we're trying to talk about here. But it's a little bit bigger, it just makes a little bit more sense for landscape lighting wire.
And then when you're all done, just to be extra sure, if you're always wondering, you can always point the connector in the upper position like you have this, so the wires are sticking down. And the reason we also do that is because as the valve box fills up with water, or the box itself, the connection box fills up with water, we can make like a little air pocket up by the wire nut. So if you didn't really get the grease over it really well, the air pocket will help keep the water out from getting into the wiring, to the bare wiring that's way up here in the very tip of the connector. So right here, let me go back. Well, I don't know if I can go back one, but right here I have the extra wire on the outside. You see that they're marked. There's actually a zip tie on the controller wire. The controller wire is the wire going back to the controller. And then on the other side of it, you can see where I've just coiled it up and put it into a valve box. That's all you need to do. Like I said, it's a little bit nicer that way. You have your strain relief is right there. You're always going to have enough wire to get back in there. In fact, in our design guide for decoders, we ask you 4 to 5 feet, and this is kind of what we're looking at.
Hey, George, can I hop in for a second?
Sure.
So, folks, if you're installing 2-wire systems, or any wire system for that matter, be it a conventional irrigation system or 2-wire, when I was contracting in the field, I used to always tell my staff, hey, when you're at that valve box, pull that wire path up at least to your hip as you're standing out of the valve box. It's just a rule of thumb. That gets you that slack in that wire path that you need. for the strain relief. But more importantly, from my perspective, when I'm coming back and troubleshooting these systems and I need access to that decoder, you see in this photo on the left, we can pull the decoder out of the valve box and service it and check it. And we can pull the splice out of the valve box and service it and check it. Trying to resplice and service a decoder while it's in the valve box, especially if it's full of water, is just very difficult. So it's really important to pull that extra slack in that wire. And it's something that when I go out in the field, I rarely see done.
Yep, and the same thing here. The guys always try to skimp on the wire, and it's usually because the installer is not going to have to come back and do any kind of maintenance or any kind of repairs. And so that's the mindset. You know, where can I save a couple bucks here because I don't have to deal with it later. So you can see this is if you have a decoder, a 2-wire path. You can see the decoder again. It's all surrounded in there. It's clean. It's not bad. It's easy to get into and repair or take a look at, test out if you need to. This is like in a regular valve box. You can see where the extra wire is there. There's the 4 to 5 feet. The connectors are pointing up, and the decoder actually has a stake. Basically, if you want to know what the stake is, it's a piece of rebar and a zip tied a piece of pipe to it. And the pipe is just long enough to keep it out of the bottom of the box, but not long enough to make the decoder hit the lid when you close it. So that's it. Again, that makes it really nice because now if the valve box is full of water or full of good old spiders, scorpions, snakes, whatever you got, you can get to the decoder without actually getting into all the other stuff. Okay. Again, on the 2-wire path market, give a guy a chance because when he walks away, the next guy needs to kind of know where he's at. When you're doing 2-wire, you can see right here the outputs of the decoder are not the 2-wire path wire. It is literally regular 14-gauge wire that I've twisted together, and that's what you want to do. That way you can see where they're going because they could be going into separate valve boxes. But this is a multi-station. You can only go about 150 feet there. But don't ever use 2-wire to extend from the decoder to the solenoid. It just really confuses the guy that's trying to fix it. A couple things you want to do. You want to cap off any unused decoder wire. So if I was only using 3 stations out of this 4-station decoder, I would still take the 4th wires coming out of the decoder and cap them off. You don't want water to get back in there. Again, I talked about color coding, stuff like that. Just make it clean. It seems like over the years we've just thrown stuff in a box and ran away. Let's take a little pride in what we're doing here to make it look good. When you get onto the downstream side, the 24-volt side on the decoder, between the decoder and the solenoid, you can use any good waterproof connection. Just like on a regular conventional system, it doesn't take anything special, just as long as it can handle up to 24 volts. Here's some of the. This is okay. You know, the different ones. The gel-filled nuts are fine if they're not going to be buried into the water. I've seen a few of these that just don't like to be in water, submerged in water. The old DS100 and the 300 is really good. Basically, in case you don't know, they make pre-filled 400s, but this one is actually the goop and the crimp connector. 2 different things. The sealant actually gets into the insulation of the wire and makes a fantastic waterproof connection. And then here we have the 3M DBO or DBYR type connectors with the grease in them. If you have really, really heavy soil and valve boxes are always in water, they can never really get cleaned out or dried out. You might even do what they do sometimes over in Arizona, which is use the 3M. And when they get all said and done, they'll put a little bit of the DS300 in the back and before they snap the cap, just to ensure that that waterproof connector, that grease and everything is intact. No water can get in.
George, I'm going to jump in here a second if you don't mind as well. And I'm going to come to you from an experience side of things here, folks. I know that we require the DBRY-6 on the 2-wire path, and we can use a different splice kit on the 24-volt side or downstream of the decoder. From experience, I can tell you with training folks in the field, I always try to keep it simple. And oftentimes I would just use the DBRY-6 on both of those splices because, again, if you introduce that additional element, that's where mistakes get made. The cost of the splice kit isn't that much. And compared to the cost of not putting the proper splice kit on the proper splice in that valve, I just think sometimes it's best to keep things simple and maybe just go with the DBRY-6s on both sides of that solenoid. Just my personal experience and opinion.
So here's a standard 24-volt system, and you're going to see the coiled wire in there. That's about 4 to 5 feet of wire coiled up. And basically what it was just coiled around a 1/2-inch piece of PVC before it's put in there. So here's my strain relief on my 24 volts. I have the strain relief. If I need to, I have plenty of wire if I need to cut stuff out, add to it, and yet it's still very clean. It takes you about 2.5 seconds to coil these things up. But again, it's also about presentation. It looks clean, it's very nice, and it hits the metal to metal, the strain relief, and the connectors are waterproof. So there you go there on that one also. So here's a couple things that we just want to make sure you got. That all 2-wire connections will be in the valve box. You're going to be using the DBYR-6s or the DBOBs, depending on what size you need, on the 2-wire path, pointing them up in the valve box. You're going to be leaving 4 to 5 feet of extra wire, like they said, about hip height on each 2-wire leg. Zip tie and mark the controller 2-wire paths. Cap off any unused decoder wires with a waterproof connector so we don't suck water back in, because once we get water into a decoder, or once you get water onto the wire path, it's pretty much there to stay. In fact, if you've ever cut copper wire and seen it black not copper, it's just a black color, you've got water infiltration on your wires. And then use any really reliable waterproof 24-volt connector on the solenoid wires. So that's your 2-wire decoder system. On the conventional, all the connections need to be in a valve box or at the valve location. You coil 2 to 3 feet each, like I showed you. You can just twist it and make it like a really nice little coil. Comes out really clean. And you can use any reliable 24-volt waterproof connector for the solenoid wiring. And I think that's just about it for me.
I'm going to talk a little bit about troubleshooting here for a moment. And this isn't a troubleshooting webinar. This is a wire connections webinar. So I'm really going to focus in on the troubleshooting aspect of a wire connection. Now, all right. So in troubleshooting, there's 3 basic factors. The controller for both lighting and irrigation. The transformer would be the lighting, controller would be for the irrigation system, then the wiring that connects the power from the controller to the fixture or the solenoid in the field. So your 3 dynamics are control, wire, and the actual device that's being activated. Now, you might argue that in irrigation systems, there's another factor, and that's the water. So if you go out to troubleshoot a system and nothing's working at all, first check the water source to make sure it's on. Okay. Now, if the controller is working fine and water is going to most of the system, but maybe 1 or 2 stations isn't turning on, or maybe in your lighting system, if the transformer is working fine and most of your lights are working with the exception of 1 or 2, you're probably good with your wire and your transformer controller. Now, in some cases, you could have a cut in the wire that was isolated to just a couple or 1 fixture, but most commonly, if everything else is working fine and you know that that solenoid or that fixture is good, and you can test that by taking the fixture off of the wire path and going to the controller and activating it, or actually taking a 9-volt battery out in the field and just touching it to the connectors and see if it fires on. Now, a solenoid, it takes 24 volts to pop, so if you were going to do that same thing, you could do that. You could do an ohms or resistance test on the solenoid. Each manufacturer is going to be a little bit different, but if you're using a Hunter solenoid, you're going to get 24 volts of power, or sorry, 24 volts of power, yes, but 24 ohms of resistance as well. So if you were to disconnect that solenoid from the wire path and put your leads from your voltmeter on there, you would see 24 volt or 24 ohms of resistance. Now, if you got that and all of the other stations in the system are working, you can probably bet that it's going to come down to the connection at that point. Some of the things that I want you to look for when you're in the field for a bad connection are as follows. Here's an example of immediately identifiable bad connection. You look at this and you immediately know that there's something wrong because the wire cap's not attached to the wires and that wire is completely corroded. Now, I want to point out that the issue here is that it doesn't really cover, it may cover 1 requirement from what Ryan was talking about, metal to metal connection, but if it's not waterproofed and it doesn't have tension relief, then it's going to fail. This had water intrusion because it was not waterproofed, and you can see that the corrosion in the wire completely disintegrated that connection, and now that system's not working. So you open it up, immediately you know there's an issue. This next one, it's not quite as easy to spot. If you opened up this valve box, you might see, oh, look, they use waterproof connections. It's down there in the bottom of the box. That's probably not the connection. But you would be overlooking the actual problem, which is very visible now that you've probably had some time to take a look at it. But you'll see that in this case, rather than cutting out the wire splice and remaking it appropriately, somebody came by and they said, we're going to add on maybe a decoder to this wire path, but we're not going to use a waterproof connection. We're just going to cut the coating back on the wire and wrap the decoder wire around that 2-wire path. Now, it probably worked for a couple of days, maybe even a couple of weeks or a year, but that's going to fail, especially in a 2-wire system where you have electricity moving down the 2-wire path constantly. As electricity moves down a wire between the copper and the coating, you're actually creating friction along that path. Just like when you're pumping water down a piece of pipe, there is friction because of velocity. Now, what that friction does as the electricity passes across that path, it can actually leak out there, but it'll also pull moisture into the path like a vacuum. So now you have this exposed connection that could compromise the whole system if this is at the beginning, the middle half or the second half of the system if it's in the middle, or maybe just the end of the system. This is a big, big, big no-no, especially in two-wire systems. But in any case, if you need to repair something or add something to the system, do it appropriately, following all of Ryan's specs on waterproof, good metal-to-metal contact, and tension relief. You'll see it again on the right pad there. Yeah, go ahead, Patrick.
Greg, I'd like to add something here too. So obviously we have an exposed copper wire there. And as Greg mentioned, moisture gets into that. Folks, sometimes you've caused so much damage to that wire that you have no other choice but to replace it. So again, importance of slack in the valve box so that we can actually pull that mess of wire out of the valve box and thoroughly examine it. This doesn't have a whole lot of slack in it either. So if we have to cut that splice out, we don't have a lot of room to splice it back properly. And when you cut that splice out and you start pulling the insulation off the wire, if you notice that corroded wire, and like George said, it'll be black or it may be green or blue, letting you know that water's been in there. If that's really bad, folks, I've done this 100 times. Sometimes you just have to go back to the closest valve box, check your connection there. And if you've got good copper at that valve box, unfortunately, you just have to rerun a 2-wire path from the previous valve box into this one because you've just got so much damage in that wire there.
Which is going to cost you a lot more than a DBRY-6, right?
Exactly.
Now this is just a rat's nest of mess. You see the valve box is full of dirt. So the fact that you can even access this decoder is, phenomenal in itself. But you'll look, there's a hodgepodge of different connections here. You have one waterproof connection or semi-waterproof connection with a grease fill. The rest of them are non-waterproof connections. You'll notice that at the top of the screen, there's the yellow and red wire connection that looks like it has maybe some Christie's glue pumped into it or some sort of backfill glue. That's not a good waterproof connection, and it's going to fail. So this whole thing is just bad in general. Now, I'm sure you deal with it a lot. I know you don't install it this way, but after it's been installed in the field, this is what you come across. So spotting this right here, even if some of those valves are still working, I would say, you know what, it's worth my time to tell the customer that we need to fix this and go back in, cut all those wires back, make sure they're good, and put in waterproof wire nuts, because if it's not failing now, it's going to fail later. So I would just recommend taking a look at that and not just overpassing it saying, hey, it's working, I'm going to move on, but saying, hey, there's a problem here, and I want to let my customer know, because if my customer knows that I'm looking out for them, maybe they won't care so much about the money, but the aspect of how much it would have cost them if I had to come out here and troubleshoot the system. So think about that.
Greg, I want to jump in again there too. From experience, again, your customer's typically uneducated about this, so it's your job to educate them in these situations. If you see those kinds of splices in every valve box, you really have to go in there and let them know that the splices are not proper in all the valve boxes, and you should give them a proposal to fix all of them. If you just fix the problem at hand, you are surely going to have another issue down the road on another valve boxes. And in the customer's eyes, they're going to say, I just paid him to fix this. Why do we constantly have issues on this 2-wire path? They don't know what they're doing. So don't just fix the problem at hand. If you identify these other issues on the site, be proactive, let your customers know about these things, give them a solution to fixing them. That way, when you do have issues down the road, if they chose not to deal with them at that point in time, you've covered yourself in that situation.
Fantastic point.
Can I say something too?
Sure.
I just want to reiterate what Patrick's saying. I've gone on many sites where I've gone into a valve box and saw that. I go into another valve box and I'm just seeing a whole bunch of wire connectors that aren't installed correctly or the wrong ones. And I just look at the guy and I just say, well, you're going to fix this, but you got time bombs going off all over this place. And you need to let the management or whoever owns the property know what's going on now, and that you can see that there's going to be other problems and that you'll take care of them when they happen. A lot of times, as long as they are aware that this is what's going to happen and why, it takes a lot of the frustration out from the management people or the people that own the property, because you've already announced to them, hey, this is what's going to happen. I can fix this. Later on down the road, we're going to have more issues, and this is why, but we'll fix them as we go. At least that is their expectation at that point. If you don't tell them that and you continue to have problems, then that's when, like Patrick says, they look at you and say, don't you know what you're doing? How come these things keep failing? Because they see a failure. They don't see a specific failure. They see a failure every single time.
It's even worth it if, to lead off of that, take your customer out in the field. Sometimes they don't actually look at any of the irrigation installation. Show them what a good installation looks like after you've done one of them. Say, hey, let me do one of these valve boxes for you to show you what it should look like. Take them out there, show them what a good one looks like, and then take them to the next one that was what that one looked like before you fixed it. And they'll immediately go, oh, I see what you're talking about. It no brainer, go for it. But so on this slide though, there's a few things that I want to point out. The first one's very, very obvious. Okay, we use the Drycon DS 100-300 combo, but we didn't actually use the 300, the goop that fills it in, which made this connection compromised. So the cap came off of it. The wires are exposed. It might still be working now, but that's going to be an issue if it's not already. Now, we use some waterproof connectors, and then on these connections, we didn't. Now, I think the yellow wire is tracer wire, so that's not quite as important, but you still want to have those connections because when you need the tracer wire to trace out the system, if it's corroded and it's got damage and you can't actually send a signal down it to trace, you're going to shoot yourself in the foot. So make sure that when you're installing these systems that all those connections are waterproof to just cover yourself. Now, this next one is less obvious, and hopefully I've given you guys a little bit of time to think about what it might be on the screen. But if you look, this next connection is right there. It wasn't immediately noticeable, but there is exposed copper wire on that connection. It might be a sound waterproof connection the way it was installed, but because the coating wasn't cut back to the same length on each set of wire before you installed it or before you inputted it into that connector, you have some exposed wire. And what Patrick talked about earlier with that leakage, just like in a connection for your irrigation system, if you glue pieces of pipe together and you miss glue on one side, there's a good chance that that piece of pipe is going to leak. Now, if you don't cut that wire to the same length and you don't have all those connections tightened up in the same spot and in that waterproofing, there's the fail point right there. And it's not immediately noticeable, but it's something that you should be looking at when you open up these valve boxes. If you're making a repair or you're in the valve box for maintenance anyways, take a look at all of the connections and inspect them deeply to make sure that you have that. Also look for nicks in the wire, because nicks can cause issues too, and sometimes that nick can be just down from where the connection was. Also, like George mentioned early on, if you've nicked that wire, you've compromised the integrity of the wire itself. You've lessened the amount of surface area that it has for electricity to travel through that connection, and it's weak and could break. So there's a few things to think about in that situation.
Using these type of connectors like you had back there, the black ones, the DS ones, when you push that cap down, you should see a little bit of whatever's gel filled or whatever's in there should be squirting out where the wires are pushed through that cap. If you don't get that little bit of a squeeze or that little bit of squeeze out, there's a chance that you're going to have an air pocket in there, and you can't be guaranteed that all your wire is inside that gel. So when you snap them down tight, you should get that little bit of around the just a little bit around the wires where they're sticking through that cap.
Perfect. I want to show you this connection, and you may be thinking to yourself, hey, they didn't push that wire nut all the way to the bottom like George told me to. Well, there's a more immediate connection issue, and that's up above, where rather than cutting off the connection and remaking the connection, they simply cut the wire and just twisted it together. Now, that may work now, but it's going to fail later. Ideally, we'd cut that back. We'd make a good metal-to-metal connection, push that connector all the way to the bottom of the tube, burping it like George mentioned, and then put the cap tensioner down and make sure it clicks on both sides so you have good strain relief inside that connection. Now, the one on the right, these are common connectors in lighting and sometimes used in irrigation too, and that's the package type connector where you put the wire nuts on, you put it in the connector, and then you fill it with goop, and then you zip tie it off. In this case, it was electrical tape, but they didn't use enough of the connector goop, and it actually had water intrusion and stopped working. Now, you would think it's a good connection, but I would avoid these if you're not very familiar with using them because they are messy, and like in this case, sometimes you don't put enough goop in and they're tough to use. So the waterproof connectors, the DBRY-6, highly recommended, but there's definitely options there. But if you look right behind the connection, you see bare copper wire where there was a bad connection. So again, you look at that connection, you automatically assume that that's bad, and it was, but there's also another aspect to that connection that could fail. So in this one, I kind of like to say, all right, what is wrong with this wire connection? And if we know anything about a DBRY-6, you can immediately spot that, oh wow, that wire nut doesn't look red and yellow. That wire nut's black. Well, why is that wire nut black? Well, this is why it's black. Because we've used a King gel-filled wire nut to put on the wire and then try and shove it in the tube. It was not designed to fit in that tube. So by thinking that you were going to do a double take on wire waterproofing and putting a waterproof wire nut inside of a waterproof gel-filled connector, you're actually not doing anything but compromising that wire path. So something to look at there where, hey, it might seem like a good idea, but it's not. Now, what George mentioned earlier, where if you did put the red and yellow connector all the way to the bottom and then added maybe some DS300, the blue goop in there to double waterproof it, that might be a better solution, but this is not doing yourself any favors. But they're trying. They're trying to do the right thing. This is all on the same site, by the way. Walking around, it was incredible to see how many different connections there were. So on this one, obviously no waterproof connection, so we fail. Boo. Now this next one, very next valve box I go to, hey, at least they have the wire connectors on there, right? So we're progressing and it's getting better, but still not waterproof. And you can see that that spare wire there is exposed and doesn't have any protection on the end of it, which could cause a problem later for that spare wire if you needed to use it. But it gets better. Now we've started introducing the waterproof connectors to the valve box. It's not on the connector, but it's in the valve box. So we're getting pretty darn close here. Lastly, we come in, and this was the best of the best that I saw on this site. They had the connectors, they were waterproof, the caps were all closed down. But if you'll notice, I mean, some of these, the connectors barely pushed into the tube, some of them a little bit more, but none of them are pushed to the bottom. So this could be a potential fail down the road. So I wanted to point out these things because they're common issues that you see, and you may be thinking to yourself, well, how do you mess up a wire connection? It happens all the time. So the bottom line is, don't neglect the connections because they are your lifeline in the communication between the wire and whatever you're trying to power in the field. So while I look at what questions have come in, do you guys have any closing comments that you want to bring up?
I'll jump in, Greg, and just say that on wiring systems, it's very similar principles to the piping system or water. When we have bad connections and we have problems on the wire path, we're just leaking electricity as opposed to leaking water. So as you're looking through this, think of the wire path kind of as pipe. And if you see exposed copper or nicks or anything like that where we could possibly leak electricity, leak amperage, that's where your issues are going to be. So keep that in mind, keep it simple, and do the right thing the first time, and you won't have these issues, and you won't have to call myself or George to come out there and help you find all these ticking time bombs.
The one thing I wanted to add from a lighting perspective is that when we, especially if we talk about the two-wire system for irrigation, the two-wire version for FX is obviously the Luxor. And when we're talking about voltage and making sure the connections are good, sometimes the connections are good enough to get at least transfer the 12 volts of power, but not always good enough to transfer the signals coming from the Luxor through that two-wire path. And so you do want to make sure that you're securely taking care of those connections, not only to just do the voltage, but to help pass the signals as well. Because those are two different things in a sense.
That's a great thing to bring up. Thank you, Ryan. Now I got a question here. Ryan, why don't you answer this for the lighting side, and then Patrick or George answer it for the irrigation side. Some of the technicians this person mentioned are using heat shrink tubing to make the connection between the controller and the solenoid valves. And sometimes they excuse us for the 230 volts, but is it acceptable for low voltage in this application?
So I just want to make sure I understand the question. So the question is it acceptable to use heat shrink connections for low voltage? Is that correct, Greg?
Yes.
Right. So the answer is absolutely, right? Because heat shrink in many cases comes with a little bit of a liner inside to add additional waterproofing. Though those are always the best versions of that to use. So I always recommend doing that because splices are, and really we could add a fourth pillar if we really wanted to. We talked about strain relief, right? That's usually, the heat shrink tubing kind of helps mostly with that. You got the metal to metal contact. You have waterproofing, which heat shrinking does. And then lastly, what some people use as a splice is permanent. So heat shrinking definitely is done in such a way that it makes the splice permanent, and that's really the ultimate connection right there. So absolutely.
So on the irrigation side, as long as it is a waterproof type heat shrink, like Ryan said, and that it's rated for the voltage, at least to the voltage that you're using, you're good to go. So if you're using the waterproof type heat shrink that's good for 230 volts, up to 230 volts by UL, you're not going to run into anything that high on the downstream side of the controller, whether it be a decoder controller or standard controller. So yeah, you could go ahead and use those. I've seen them used before, but again, it has to be the heat shrink that is meant to be used for waterproofing and wiring. Not the regular heat shrink that you could buy at an electronics store that just basically is, just a heat shrink around wire.
Good point. That's that's a really great point. And on top of that, I would still suggest you have that extra slack in the valve box if you're going to use those types of connections or at the fixture itself to prevent, expansion and contraction and have that ability to service that wire later on. Because even if that is a great connection, sometimes one little thing goes wrong in making the connection and it fails, which happens, or you need to go in and replace a solenoid or a fixture and you need to cut that section out. So definitely leave yourself that extra slack there too. We got another question. What do you use when capping unused valve leads on your decoder? A gel wire nut or waterproof?
Well, in reality, on a decoder system, you probably are not getting on the commercial side, you're not getting too high of a voltage. So as long as it's a 24-volt waterproof connector, that's what you're using on that one. Do not put both wires in the same connector. Each wire has to have its own so it doesn't accidentally short together. But yeah, just any standard 24-volt waterproof connection should work.
Also, feel free to reach out to us after the fact, training@hunterindustries.com. If you have any questions, send them our way. And if I don't know what the answer is, I know a bunch of people that probably do, so I'll make sure that we get that question answered for you. Thank you all for being on the call. We really appreciate your time and your business. And from the bottom of our heart, we want to thank you for always supporting Hunter Industries and supporting us in our efforts to train and get the information out there. So if you see another email coming about a webinar and you thought this one was good, pass it on to a friend that you think might be interested in it as well. Don't forget to check out training.hunterindustries.com for all of the other training opportunities we have, the YouTube channel, and also make sure you go check out that Rev It Up campaign so you can start earning coins today. Again, thank you so much. We hope you have a great evening, great afternoon, or great morning wherever you are. Have a great day.